All right, team, settle in. Today, we're diving deep into something I call the silent killer in modern engines, GDI carbon buildup. Now, this isn't just another line item on a maintenance sheet. Nope, this is a fundamental design issue, and understanding it is what separates the real technicians from the guessers. Okay, let's get into it.
So, imagine this. A customer brings in a fairly new car with this exact complaint. There are no check engine lights, and it seems to run okay once it's warmed up, but they swear it's just lost that punch it used to have. Now, a parts changer might start throwing plugs and fuel cleaners at it, hoping something sticks, but we're smarter than that. This right here is the classic symptom of a problem the car's computer, the ECU, is trying its best to hide from us.
These are the first whispers of a much bigger problem on the horizon. The owner might not even notice that 3% drop in gas mileage, or they'll just get used to that little stutter on a cold morning. But for us, these are the breadcrumbs. Think of this as a checklist for the owner. They can spot these things before they even know they have a real issue. These are the telltale signs that the engine is slowly but surely being choked from the inside out.
So here's our plan of attack for today. We're going to trace the symptom back to its root cause. We'll get into the science of the gunk itself, learn how to decode what the engine's computer is telling us, or hiding from us, and finally, we'll nail down the only real long-term fix.
Right. We're calling this the phantom misfire for a reason. All the symptoms, the hesitation, the rough idle, they scream fuel or ignition issue. But the real culprit? It's physical. It's a mechanical obstruction, and let me tell you, no fuel additive or new set of spark plugs is ever going to fix it. This is an airflow problem, plain and simple, and it starts with the very design of the engine.
And this right here is the dirty little secret of GDI. In older port fuel injection or PFI engines, the fuel was sprayed on the back of the intake valves. Think of it like a constant shower. The detergents in the gasoline were always washing those valves clean. But with GDI, gasoline direct injection, that fuel goes straight into the cylinder. It's fantastic for power and efficiency, but it means those poor intake valves are left completely high and dry with nothing to clean them.
So, if fuel isn't hitting the valves, what is? Well, this stuff. Blow-by. Every engine has it. It's this oily, gassy mist that sneaks past the piston rings. The PCV system, it does its job. It sucks these vapors out of the crankcase and routes them right back into the intake manifold. Now, in a PFI engine, this gunk just got washed away by the fuel. But in a GDI engine, it hits those hot, dry intake valves and it sticks like glue.
Okay, time to put on our lab coats for a minute. To really get why this problem is so stubborn, we have to look at the actual science, the chemistry and the thermodynamics happening right on the surface of that valve. It's a perfect storm of heat and nasty chemistry.
Now this is fascinating. The side of the valve facing the combustion chamber gets blasted to over 800 degrees. It's way too hot for anything to stick. It's basically self-cleaning. But the back of the valve on the intake side, it lives in this Goldilocks zone. It's not hot enough to burn the oil vapor off cleanly, but it's the absolute perfect temperature to slowly bake that oily blow-by into a hard, crusty carbon deposit.
And when we say carbon, it's not just simple soot. It's a nasty, complex chemical cocktail. We're talking hardened hydrocarbons, varnishes from cooked oil, and even metallic ash from oil additives like zinc. This stuff chemically bonds to itself layer by layer, building up this incredibly tough matrix on the valve.
Man, get this. We're not dealing with some soft sludge here. On the Mohs hardness scale, mature deposits can be as hard as a mineral, like calcite, as hard as a rock. So when you see someone spraying a can of cleaner into the intake of a high-mileage GDI engine, it's like trying to clean a brick wall with a squirt gun. It's just not going to work. And here's the physical impact of that buildup. Just a couple of millimeters, we're talking the thickness of a nickel, can choke off airflow by more than 10%. Once you get to 5 millimeters, which is pretty common on a neglected engine, you could be losing almost a third of your airflow. The engine is literally suffocating.
But it's even more sinister than that. It's not just about blocking the air, it's about wrecking the flow. Engineers spend millions designing intake ports to make the air tumble and swirl as it enters the cylinder. This tumble is critical for mixing the air and fuel properly. When you get carbon buildup, it destroys that carefully engineered shape. You kill the tumble, you kill combustion efficiency. That means less power and worse mileage, long before the computer is smart enough to throw a misfire code.
Okay, now for the detective work. The ECU is smart. It knows something is wrong and it tries to compensate. But those compensations, they leave a trail of digital breadcrumbs for us to follow. The ECU is essentially lying to keep that check engine light off, but if you know what to look for, you can read its data stream like a book.
Clue number 1, your long-term fuel trim. When you see a high positive number like this, plus 12%, it means the computer is consistently dumping in way more fuel than it thinks it should have to. Why? Because the airflow sensor at the front measures all the air coming in, but thanks to the carbon, less of that air is actually making it into the cylinders. So the oxygen sensor downstream sniffs a lean mixture and starts screaming for more fuel. This is the ECU's desperate attempt to fix a problem it can't see.
And here's clue number 2, ignition timing. That terrible air-fuel mixture we just talked about makes the engine much more likely to knock. The knock sensors hear that, and they tell the ECU to pull timing back to protect the engine. But there's another thing happening. Those carbon deposits act like little insulators, creating hot spots on the valves that can cause pre-ignition. So the ECU is fighting a war on 2 fronts. Seeing the computer constantly pulling timing like this is a massive red flag that your combustion is unstable.
So, we've diagnosed the cause, we've confirmed it with the data. Now for the most important part, the fix. Let's talk about the right way to clean this mess up, and more importantly, how to stop it from coming back.
Let's be crystal clear about this. Fuel additives? Useless. They never touch the valves. Aerosol cleaners? They might soften up some very fresh, early-stage gunk, but they won't do a thing to that hardened, rock-like carbon. The gold standard for removal is physical cleaning, and the gold standard for prevention is stopping that oil vapor from getting to the valves in the first place. And that physical cleaning method is called walnut blasting. It sounds weird, but it's brilliant. We pull the intake manifold off, rotate the engine so the valves for one cylinder are closed, and then we use a high-pressure wand to blast the deposits with finely crushed walnut shells. The media is just hard enough to strip the carbon away, but it's soft enough that it won't damage the metal valve. Then we vacuum everything out, and you're left with valves that look brand new.
Now, this is the playbook. This is what you tell your customers. First, a good quality oil catch can will literally catch a huge chunk of that oily vapor before it gets to the intake. Next, and this is key, use a true full synthetic oil with a low NOACK rating. NOACK is just a measure of how easily oil evaporates under heat. An oil with a NOACK score under 10% means way less oil vapor in the system to begin with. You combine that with a scheduled cleaning every, say, 40 to 50,000 miles, and you can manage this problem for the entire life of the car.
And all of this brings us to the bottom line, the part that really matters to the customer. This isn't just a technical problem, it's a financial one. The choice we present to them is actually pretty simple. You can pay for proactive maintenance now, a few $100 for a walnut blast service. Or you can ignore it until a chunk of that carbon breaks off, gets stuck in a valve seat, and torches the cylinder head. That's a repair that costs thousands. This isn't an upsell. This is saving your customer from a massive, catastrophic repair bill down the line.
So here's the big takeaway. GDI carbon buildup isn't a defect. It's a characteristic of the technology. It's the trade-off we make for better fuel economy and more power. Our job, as professionals, is to understand it, explain it to the customer, and manage it. That's how you turn a potential disaster into nothing more than routine maintenance.
You've got the whole picture now, the physics, the chemistry, the economics of it all. So the question I'll leave you with is this. What kind of tech are you going to be? Are you going to be the one who proactively manages the known flaw? Or are you going to be the one who just waits for the inevitable, expensive failure? The choice is yours.